I took a nap yesterday. As soon as I got home from school. It was an awful idea because I couldn't go to sleep, and I only studied for like. It was a bad idea. But I couldn't keep my eyes open, so I just like.
Sometimes you gotta do. You gotta do.
Well, I never take naps.
You plan to take like 20 minutes and then it turns into 2 hours.
Yeah, I went to bed when I got home. I didn't get up till like 6:30. So.
I've gotten to the point where I come home, I sleep for 2 or 3 hours, then do a bunch of stuff, and stay up till midnight, then wake up exhausted the next day and just do it all over again. Terrible way to live.
It's a cycle. It's a deadly cycle. No, did you guys see the clouds? We're all gonna die today. I swear. Look, like, it's horrible. Like, I was driving, this was like this huge, just a black cloud, and just like, horrible.
Alright.
It's a good way to start off your
I'm
day.
glad I've been recording for the last couple of minutes.
Oh.
Units 10 and 11. Unit 10 was our acid-base chemistry. Unit 11 was just a little bit of our nuclear chemistry. This is probably the freshest. I'm just guessing. So I'm guessing you guys will rock this. Where do you want to start?
Classification of acid.
Okay, it started to get a...
No, let's go what he said.
Okay, classification of acids and bases. Okay, so here's our substances. 18 molar sulfuric acid. Decide is it strong or weak. If it's strong or weak, is it an acid or a base? And then is it dilute or concentrated? You guys just want to talk about?
Yeah.
18 molar, concentrated or dilute?
Concentrated.
Concentrated. What's your cutoff?
1.
1. Greater than 1? Yeah, this is the acid that makes me very nervous in the lab. But we do have 18 molar concentrated sulfuric acid. It's almost it's a little syrupy because it's so concentrated. Like you can tell it is a little thicker than normal water. And yeah, very careful. Always very careful. Goggles, aprons, gloves.
Have we used it this year?
We have not. We've used 0.1 molar sulfuric
Oh,
acid,
wow.
which would be considerably less concentrated. If not treated, it could.
So that would really burn.
Yeah. This is like if you spill on the floor and the bottle breaks, you get to get new shoes because it'll start to eat through your shoes.
Oh, that'd be fun until it like hit you.
Feeling love, guys. Feeling love. Sulfuric acid, strong or weak?
Strong.
Strong. H2SO4 is a strong acid.
I have
Good.
to memorize this.
0.5 molar, concentrated or dilute? Dilute. Calcium hydroxide, acid or base?
Base.
Base. Strong or weak? Strong. Good. 0.1? Dilute. Acetic acid? Weak. Remember, this is your vinegar. You drink it. Better be weak.
Oh, that's right.
4 molar?
Strong. Oh no,
Concentrated.
Concentrated.
Okay, now.
Concentrate.
Strong and weak, we look at what?
The acid.
The type of acid. Concentrated or dilute, we look at
How much of it?
molarity, the
Strong
concentration.
listed first.
Yeah, you always look at that.
4 molar, concentrated or dilute.
Concentrated.
Concentrated. Ammonia, NH3, strong or weak base. Is there a hydroxide in there? It is not an acid.
This one always.
This is one of our bases by the Bronsted-Lowry definition.
Oh yeah, because can't it like give away?
Not because it donates a hydrogen, but
It can
because
take one to make
it could
NH4.
accept one. This could accept a proton to form NH4 1 plus ammonium. We know this exists. We've seen it as one of our polyatomics on many of our compounds. Because this can act as a proton acceptor, Bronsted-Lowry definition says that it is a base. However, there's no hydroxides, which is a really good indicator to you, hey, I bet this is weak. Right? If remember there were 2 weak bases we talked about? There are more than just 2. These were the 2 I wanted you guys to know. Aluminum hydroxide and ammonia. 3 and 3.
Oh, that's helpful. I remember that now.
Is that thunder or something?
And no, it's like a huge storm cloud.
From?
So I missed the day where I had the discussion of strong and weak bases,
Hmm.
bases and acids. So how do you tell the difference between?
Gotta memorize them. Yeah, there's just, these are the certain types that don't break apart. These are the ones that do. Strong acids being ones that dissociate completely into water. Weak do not. Sorry. This is one of those. Gotta get them in there. It's more time and energy efficient if you remember the weak ones than remember all the strong ones. So those are our weak bases. For our weak acids, we know we've got vinegar. We drink that. We've got carbonic acid in our sodas. We also drink that. Phosphoric. I think those threes again. Phosphoric. Hydrofluoric.
There's only 4.
Those are the 4 we talked about.
Wait, is hydrofluoric strong or
A weak.
weak?
But fluorine is super greedy. It really holds on to the electrons. Strong bond. Weak acid.
But doesn't hydrofluoric like eat through everything?
In high enough concentrations, it will. Cool. Good discussion. I like it. We're off the script. All right. Feeling okay here? Whoop. That's what I meant to hit. Ah. Nuclear pens. We're okay with that?
Sure.
You just got represented. You just got to be the class representative. That is not a pen number. Uh-oh. We're broken. That's not where that's supposed to go. Let's do that. Ah, there we go. There it is. Sorry.
Oh, these are fun.
Okay, we'll do the first one together and then I'll let you guys do the rest. Iron 57, what's that dash 57 mean? The mass of this particular radioisotope, or this particular atom, is 57. How do you get your protons for iron? Iron. Periodic table, Fe is 26 protons. Is there a charge on this iron as it has been described to you? No, which would mean that if you have 26 positive charges, you would need to have how many negative charges?
26.
26. 26 positives, 26 negatives, charge of
0.
oh, atomic number? 26. Same as protons, all except for the neutrons, no charge, but
So minus 26.
30.
mass of 1 AMU, so 57 minus 26 gives us 31. You do the other two.
Mental math. Wait, why? I was like,
Should we keep our periodic table in the summer?
Have you written things on it? If you've made notes to yourself, I would suggest it. But the back is very helpful as well. Oh, we were talking about that. We weren't sure whether or not we should have a summer assignment for college chemistry.
Why did you do that?
They always have a summer assignment for AP chemistry. College chem kids always prepare for AP chem.
that's just me.
Is it like a
Like,
project?
what do you have to do?
I think it's like a 6-page packet.
Ugh.
Our study guide is that long.
It just keeps you fresh. Refreshes some of the
Wait, so, like, you don't actually have to complete it, do they?
Oh, you do. It's first grade assignment.
Oh, so it's a grade for, like, the first grade for AP. That's just mean.
Look, it's like 100%. Right?
Mhm.
It's pretty much like a free grade.
It's all review.
But it's the summer.
And there's a help session.
I don't do anything in the summer.
Who's got carbon?
6, 8, 6,
6, 8.
6, 14, 6, 0.
Cool. What?
Math.
They said that number of neutrons is math. Apparently, we're done reviewing.
Yes. Okay. So just a survey here. How many of you are taking college chem?
Wait, if we say yes, we don't.
I'm just curious because I like seeing students here willing early to review, and that doesn't always happen. Kudos.
We were just talking about the summer assignment. Have you got that put together for college, Kim, yet?
I'm thinking about it. What do you guys think?
Okay, you can do it this year. Next year, when we have it, you can just skip that part.
I was thinking about giving you guys an assignment.
Oh,
That.
that would be horrible.
Well, don't forget everything over the summer. 'Cause that happens.
Way ahead of you, don't
Wait, wait.
Not fun.
Was that an acceptable answer on the final?
No. I don't know if this video is going to be any good now. 125?
It's 120.
Yeah.
You just did that. And
Put a key 125.
Number of electrons. We have 82 protons. We got a plus 2
80.
chart.
I got this.
80 electrons. Mass number?
82.
Oh,
Top number?
82. There you go.
3 points? Yeah. 3 points. You guys really good at those.
You should just do like half the test.
Just that, yeah.
Just that.
Yeah.
Will the periodic table that we have on the final be a piece of paper or the plastic ones?
I actually have written, run off a piece of paper once so you can write on it.
Okay.
Let's go to properties of acids and bases.
You okay with that?
I bombed that part.
Yeah, me too.
Complete the table. How does an acid taste?
Sour.
Sour? Base?
Okay, I have a question about that. So, coffee's an acid, right?
Right.
Why does coffee taste bitter then?
That's when you talk about taste, it gets a little tricky just because taste is different for everyone. How we perceive that taste is different. Can I give you a different bitter taste? I don't know. This probably has never happened to you, Katie. I'm sure it never has.
Yeah, okay.
But if you've ever been at home when you were younger and you accidentally said a bad word, and your parents took that bar of soap and
Yeah.
washed your mouth out with that soap, that's bitter. And we know that soap is a base. We know it cleans the acidic
I
or
should have tried soap on myself.
the. Good for you. See, my mom was really mean. If we swore, she wanted to make sure we really knew that we had sworn. And so she would take, it would be the liquid soap, so she could squirt it way back in the back of our mouth, instead of just like right at the front. So you'd have to sit it Acids feel really nothing.
Slippery.
Bases are slippery.
I got that.
Okay, see, I missed that one because I had no idea.
Bases are slippery. We clean ourselves with the base. pH value. Acids are low 7. Bases are
Above 7.
what's 7? Neutral. Arrhenius. What's your Arrhenius acid particle?
H plus.
H plus to form hydronium. Arrhenius base.
OH.
OH minus. Bronsted-Lowry. Acids are
Donors.
H plus givers.
And
Donors.
H plus taker.
H plus stickers.
Wait, so both of those definitions right? Or
Yeah, you can describe an acid as either an H plus ion in water, or you can say it is a proton donor. Base you can describe as having a hydroxide ion, or being a proton acceptor. Lewis, ooh, we didn't really talk about Lewis so much. Anybody remember?
Yeah. Acids
It flips.
take
Acids are
electrons.
electron receivers,
And bases give away
electron donors. We kind of flip-flop because electrons are now negative.
electrons.
Flip-flop.
Flapped.
Hey. Nice to Alright. Go next.
balancing equations.
Alright.
This one has to do with math. No, it doesn't. Okay.
Oh, I love it. 3 rows, 3 problems. 1, 2, 3. Take that back. Sorry, you're 2. Okay. There's just a little bit of lot of you guys.
Yeah.
Oh, not only do you have to provide the formula for the products, but you also need to predict the formulas for the reactants. You would also need to predict what products would form with the acid and base reactant. You got this. You got this.
These aren't all neutralization.
Okay, mother.
You know what?
Lesson about
Anybody got any?
Okay, I think I
Somebody, first one?
Ca and then parentheses OH2 plus 2HCl makes 2H2O plus CaCl2. And then there's the H2 is aqueous, right?
Which one? This one?
No, the H2O.
H2O is going to be just
Oh, and then the CaCl is solid.
what's the salt going to do in water?
Oh, dissolved.
So that guy's going to eat this. And then our acid and our base.
I didn't
To be reactive, we got to get these ions free from the other particles. We do have to put them both into water. We got solutions of both these guys are dissolved as well. Cool. Group 2. There's only 3 of you, so one of you is going to have to come in.
Okay, Na2CO3 plus H2SO4, and that makes CO2 plus H2O plus Na2SO4. And the first 2 are aqueous, CO2 is a gas, H2 is a liquid, and then would it be aqueous again?
The salt dissolves into the water. Good. Nice. Group 3.
Okay, we have solid magnesium. We have acetic acid, HC2, H3O2, and the nucleus. That goes to hydrogen gas, H2, and magnesium acetate. There's 2 acetates. That's aqueous.
Good.
And then we have 2 acetic acids.
Yeah.
Now this one's a little tricky because when you look at this reaction, you go, wait, how can this be dissolved in water when we've got no water in the reaction?
The other ones.
Good. When you look, your acid was already in a water solution, So when you poured that in, there was already water in the beaker with it. The salt, when it formed, then just dissolved into the water that was already existing. Good. A couple of notes I'd like to make. What are all these guys? They're all salts. Whenever you have an acid base, or sorry, whenever you have an acid reaction, you always get a salt. Note your two different gases: carbonates, CO2, metals, hydrogen gas. And notice that you completely neutralize when you get that acid and base reaction. Okay.
Is there gonna be any like number 2? Because I would probably got that wrong.
Remember that our final is all either multiple choice or matching.
Oh, that's right.
So it limits the types of questions that I may potentially ask. I might ask, which of the following would be a product of an acid with carbonate? I could ask that, but I can't ask you to write a balanced equation. I could ask for what are the coefficients on this. I could say what are the coefficients on the sulfuric acid when this reaction is properly balanced.
Or you could not.
In that event, I would still have to give you the reaction though. You would just have to balance it then.
Now, when you're naming acids with it goes A to A.
Yep.
Let's go with titration since it's the last one.
What glassware was used to hold a known concentration of base when we titrated? Burette. Measures to what decimal place? Anybody remember? 2 decimal places to the 100th of a milliliter. Incredibly precise in measuring out our volume. When do you know your titration is complete?
And the color
There's
changes.
a color change.
Color change of
The indicator.
the indicator. Good. When the moles of the acid and the base are equal, the blank point has been reached. What do we call that? Not equilibrium, but equivalence point. I know we didn't learn about it. Equilibrium is a little bit different. It is a thing in chemistry, big thing in chemistry. We did not cover equilibrium.
So if we just put that on test, we'll use extra credits. Write it.
Not if you're talking about this. Equivalence points. Good. What substance helps maintain a constant pH? What do we call it? Oh, buffer system. Good. Color does litmus change in an acid? Red. Color does change. Phenolphthalein. Oh, sorry. In a base it is blue. Phenolphthalein in acid is colorless. In a base, magenta. Good. Do I have? Nope. Would have been good to have a practice calculation. Maybe I'll make one up here. Oh no, there's another one. Sorry. Okay. Scientists. Ooh.
Ooh.
Oh, that's be good. Bonus learning.
Is that not on the final?
It is not.
Our science, our early
So,
scientists?
our early scientists are. The scientists from radioactive or nuclear chemistry are not.
I don't even know.
There. Once upon a time, we used to do a little. When we had more time, we did an informational packet that talked through some of those people. I nixed that this year just because of time.
So the only scientists we know are the early ones.
Right.
Which,
Now,
yeah.
some of these we have talked about. You guys remember who discovered the X-rays way back in Unit 3?
Curie?
That was Röntgen. Röntgen.
Well,
He's the one. Hey, Susie, I made up the wife's name. Put your hand under here, and he discovered them by accident. Big old wedding ring in the image. Okay. Gold foil. That one you should know. Rutherford. Now we've kind of got 2 left. Anybody know polonium and radium? Polonium named after Poland, the home
Curry.
of the Curies. So these two are with the Curies. Radioactivity then would be Becquerel. That's why one of the units for radioactivity is the Becquerel.
What do you mean Curie? Like there was more than one? I mean, I know Marie.
Marie Curie and Pierre Curie. Pierre was actually a professor until he suffered a tragic accident. He was actually hit by a vehicle, and so his wife took over his position at the university. So she's one of the first female
Wait,
professors at
did
the
he
level. He passed away. Yeah.
Is there a question about him getting rid of a weapon?
That will not be on the file.
I think I would remember that.
That was
Do you
only.
know that like there's a meeting this morning in
But
the
yeah, I would get it.
I was gonna go this morning, but not. Because mine popped up for 7:30. I may just go.
First off,
Wednesday. Yeah.
Yep. It is a calculation. So you might need a calculator for your calculation. Unless you're just gonna put math for your answer.
I would totally do that. You should put that like as one of the
One of
answers
the
to
multiple
one.
choice questions. I could still go in and change
I
it.
might have to click it just because there's something.
You're gonna give away one of your points on the final.
I cannot afford to do that.
I can't do that.
That is bold.
Jared of all people could do it.
Yeah.
Vance could probably do it.
Oh my god.
Ah.
What units represent molar concentration? Molar liters.
It's awesome how you put the answers and you put like moles over liters because that's like the units and so you
Yeah.
can see it.
Right? It works out nice, isn't it?
Yeah.
What is the molarity of a solution made with 1.5 grams of sulfuric acid dissolved in 250 milliliters of water? Oh, you got this.
And a card.
6 molar?
Oh, no.
I think it's
That's the answer.
Oh.
I got
it's really
I got
easy.
0,
I
0,
raised
6.
You use a card. Just ignore it.
I'm really
I
confused.
think you just put 1.5 divided by 1.
I got 20,006.
Well, what do we got to do with grams first?
Oh, never mind.
Change them to moles. We got grams of sulfuric acid, H2SO4. 98 something for sulfuric acid.
Sure, whatever you want us to make it.
98.086. For every 1 mole of sulfuric acid. How many moles of acid are we working with? Moles?
Yeah.
Do we know our moles? Do we know our liters? Change liters, move your decimal 3 to the left or divide by 1,000. I feel like we're all pretty proficient at that at this point.
We should just have like a couple questions over that. That'd be wonderful.
Why don't I just give you all A's?
That'd be a great idea. Oh my gosh.
We got our work.
Before rumors get spread, I cannot do that.
You could do that. Some other
Make
teachers
sure
are
it's
like,
easy.
if you get like A's on all the other ones, then they'll just average it up to an A.
0.06
Ooh, yeah, I bet you could complete 0.6.
It should probably be completion grade.
Sig figs, probably 2 decimal places.
No, it's 3.
Zero.
You dropped to 0. No, you didn't. Just kidding. Yeah, 0.06. Drop to 0.
Why do we put the 0 at the end? I know sig figs.
Because it has to be 1 more
This only has one significant figure.
Okay.
It came out exactly?
Yeah.
Then we would need to add that additional zero. How do you find the pH given the molarity of the acid? Negative log. Good.
We do not go by decimal places.
2 sig figs. 2 sig figs are the rules for the logarithmic scale are actually different. The pH rules are a little bit different. Technically, this would only have one significant figure the way it's written.
At this time, a presentation regarding next year's evaluation system will begin in the Little Theater. Once again, attention staff, the presentation regarding next year's evaluation system will begin in approximately 3 minutes in the Little Theater. Thank you.
Do you actually have to go to that?
Astor base. They're offering it this morning and after school. I've got it scheduled for after school today. Acid. pH less than 7. Answer me.
So the sig figs with pH are kind of sketchy. Are the answers going to be obvious?
Yeah. I would just go with the number of sig figs that you had in your calculation. Yeah. Technically, this 1 tells us what the power is on the times 10. And so that doesn't count as a sig fig. to decimals after that count as 6 digits. Yeah, don't,
Just
don't worry about that. Alright. Oh, cruising. Look. Oh, Roman.
On the test, we had several problems with acids with a pH of more than 7. So how does that work?
That as an educator,
Oh jeez.
as an educator, that is a check to see if you truly understand how to use those calculations and work through those calculatory pieces. Because the purpose of our final is not specifically acids or bases. I'm looking more holistically, not to that level of specificity. In other words, I ain't gonna do that. Fair enough?
Yeah, that's really good.
We do titration calculations.
Sure.
But I don't understand what you're supposed to round during this.
Oh yeah, I always forgot.
Because my answers are always off.
Use the titration data below to answer the following questions. You've got a volume of 30 milliliters of KOH, molarity of 0.5 molar HCl, a volume of 50 milliliters for hydrochloric acid. And we need two pieces. We need to write a balanced equation, and we need to solve the molarity of our unknown base. This, in its purest form, is a titration. How do we figure out the concentration of some unknown solution? Go back in the lab. There's a beaker. It says it's a base, but we don't know how concentrated that base is. It's worth knowing, as bases are corrosive. They are caustic. So let's start with the balanced equation. We've got Drake.
Sorry,
It's okay.
um,
You can finish before you come.
alright. HCl plus KOH equals water and KCl.
Can we throw state symbols in real quick? Acids and bases are aqueous, potato, water,
Liquid.
liquid, salt, aqueous as well. Coefficients? All ones, okay. Ooh, that makes it kind of nice. Ooh, player's choice. Would you like to use our molarity formula, the MAVA equals MBVB, or would you prefer the 3 steps, molarity, mole ratio, molarity?
Oh, I like the first one.
Attention staff,
The one where
if
you
you are
like equal them
attending
to each other.
the presentation regarding next year's evaluation system, please proceed to the Little Theater at this time. Once again, attention staff,
You
if you are
have
attending
35.6
next year's
seconds to get
presentation
there.
regarding the evaluation system, please proceed to the Little Theater at this time. Thank you.
Oh, okay. Have fun. Option 1, what are the coefficients though?
They're ones.
1 to 1, so they're gonna
Erase.
drop out. So we can actually just look at MAVA equals MBVB if we would like. So this is option 1. Okay, let me set it up. Let me just set it up and then we'll take a look. What's the molarity of the acid? 50 molar. Volume of the acid?
30. Oh no, 50.
Oh, okay, you can use milliliters in the other one.
Molarity of the base, we don't know. Volume of the base, we know to be.
30.
Now let's just talk this out real quick. We have a 1-to-1 ratio, yes?
Yeah.
And we use some amount of base, but we use more acid to get it to neutralize. What does that mean about the concentration of the base if we took more acid to neutralize it?
Be more concentrated.
It's got to be more concentrated than the acid, yes? When we do it's just kind of a nice way to frame it. Okay, our answer, when we start doing our numbers, our concentration of the base should be bigger than this because it took more of this solution to neutralize a smaller amount of base. It's just kind of a nice kind of double check. Okay? This is option 1. We can then solve for molarity of the base. Option 1. Option 2, mole ratio. Sorry, molarity, mole ratio, molarity can't get. Okay. So if we know the molarity and the volume, I'm going to go ahead and change this into liters. Given the molarity and the volume, we can solve for moles. I'm going to set them both up here. Anybody got a calculator handy? I'm going to multiply those two together real quick. Get your moles.
0.025.
That's moles of acid. We know our ratio is 1 to 1. For 1 mole acid, we got 1 mole of base. That means we have 0.025 moles of base. If we know our moles, and we know our volume, our third step would be molarity again. Our moles now divided by our liters, which was base 0.0300 milliliters. Oops, sorry. All right. This half, you guys want to punch in your calculator real quick? Solve for this right side. This half, punch in your calculators real quick. Solve for that side. Main, yeah. 0.83 molar.
Yeah.
Bigger than 0.5, right? Answer makes sense. What do we get over here?
That's convenient.
Leia's choice. What's nice when you look, guys, molarity times volume, there's your moles. It's a 1-to-1 ratio, so moles divided by liters. Same math, just different setup. Good. Mess with that one a little bit.
Let's do pH and pOH.
Okay. Not very many left. Calculate the pH and the pOH. Ooh. Assume these are all acids. Yep, I would need to tell you. Assume these are all acids. These are all the H plus, or so these are all the H3O plus concentrations. pH, what'd you get? And so the pOH should be 5. Yeah, technically I'd match it here. But if it's multiple choice, pick the one that's closest to what you got. 0.3 pOH of
0.7.
how you doing that?
14 minus pH.
Ooh. Before you get there, so you're doing what with this number? Negative log of molarity gives us pH. 14 minus pH gives us pOH. Good. You got 3.
I got 2.6.
And hit. 11 point. Oh, no, okay, you have 2. 11 and 3. Acid or base? Base, acid or base?
Acid.
Acid, acid or base? Acid or base?
Base.
How you doing? Now what?
Types of decay.
Decay. What are the 3 types of decay? Alpha, beta, gamma. Talk about most recent. Holy buckets. Which type of nuclear decay results in a decrease in both the mass and the atomic number? Alpha. Good. Which type of radiation has the least penetrating power?
Alpha.
Also alpha. It's kind of the trick question. Good for you guys. When an element undergoes radioactive decay by losing a beta particle, the atomic number increases or decreases by 1? Increases. How does that happen? A neutron turns into a proton. Good? Is that okay?
Yeah, I was just making sure that was some hidden.
Decay series. We didn't do half-life.
We did not. Write the nuclear equation for the alpha decay of uranium-235. So you start by putting your symbol, your mass number above it. I would always go ahead and find your proton count. For you, it is 92. It's going to decay in this first step. Doing alpha. Alpha is a helium nucleus. 4/2. What is our resulting daughter nuclei going to be? 231 over 90. 90 protons is. Alright, try the second one. You guys try the second one.
Oh yeah.
We did not have time to get to half-life either. We did just a little bit of it, but we did not do much with the calculation. What is the half-life of an atom or radioactive?
It's how much time it takes for half of the stuff to decay.
The amount. It is the amount of time it takes for half a radioactive sample to decay. Good. Any other questions? Nuclear acid base? Finished early. Alright, that's all I got. If you got any errands or any items you got to take care of before class starts, feel free.
It's like 100 of you.
Let me take a selfie. This guy goes up. I really got nothing left. Like, that's all I had prepared for this morning. So thank you for your time.
Thank you.
Thank you for coming in early, guys. Appreciate you guys giving some of your time to come on and get a little extra practice.
Just so that my login is good.
Yep, that's fine. Yep. Let me take a selfie.
That song though. That's why I don't.
What?
Should we be scared for the final?
Ooh, can you see how much I can get on the final so I keep my grade as an A? Like, if I like get a 50 on it, well, just, I don't think I will. I think I'll get it, hopefully, since I come to the study sessions and I've studied, get a good grade.